Hey, welcome to your Google Classroom for Earth Science. So, my name is Kelly Hart. I'm your teacher, of course, and I'm so very happy that I've met you all today, and hopefully I'll meet even more students tomorrow. So, this is the platform that will allow you to see all the assignments. Let me turn off the music in the background. Anyway, this is the platform that allows you to see all the assignments, and I also post video to help with each assignment that goes along with what we're doing in the classroom. And this purpose is for if you're not here for the day and you miss out on things, I don't have to reteach stuff as much, okay? Also remember, in Earth Science, you're going to have homework every day, Monday, Tuesday, Wednesday, Thursday, and Friday. And remember, the point is because we only have 8 weeks to get through the entire curriculum of Earth Science. Again, like I was saying in class, normally Earth Science would be a year long with 8 or 10 or 12 units within each section of a book. I have 1 week to get through each unit. And a week for us is only 4 days a week, remember. So yes, it's going to be a lot of information, and I'm counting on you to do a lot of assignments on your own. But of course, I'm always going to be there to help provide help you with help and provide the help that any help that you need. So I hope that's understandable for us all, and that everyone understands that you can pass this course. This course will be so easy if you're here. If you're here, you'll know exactly what's going on. And even if you're not here, you'll get a tidbit of what's going on through the Google Classroom and what I've been posting every day for the Google Classroom. But it's much more effective if you're here. Not to mention, you like my class. And I'm so happy to be a teacher here, and I want to make sure I keep it live and popping and keeping everything fun in the classroom, okay? So this is what's going to happen. As you can see in the Google Classroom, and this is my first Earth Science, but the second class of Earth Science, it looks exactly the same, except your background is going to be like the blue. And then the first class of Earth Science, I have the background is purple, but it doesn't matter because I post the same thing in both of them, okay? So here's the thing. So we went through the syllabus today, and for Earth Science 1, my first class of Earth Science, I actually gave some of you access to the Kami account, which allows you to do the worksheets online. Virtually through an app that allows you to submit the worksheets that are online in this Google Classroom. For my second period of Earth Science, that'll be the ones that are in the blue class that has the blue background. We'll be going through that tomorrow. And I also want to make sure that everyone realizes that it doesn't take a whole lot to use Kami. It's just that if you're afraid of computers, we need to get over that fear. Now, I did say that I'm still going to be printing out information for you, but by the second or third week, I'm hoping not to have to print as much. This is, let's save the earth, okay? It's Earth Science. We should be doing something like save the trees, man, save the trees, okay? If you are not liking the technology so far, you're going to have to get used to it because this is the working world. It's the 21st century. Computers are in. And so I'm hoping through this class I can guide you and make working online a little bit less scary for you, all right? So this is what's going to happen now for the rest of this video. As you can see, you have the syllabus. Most of you guys already signed that in class. If you are not in class, you can click on this. You can download it, print it, sign it yourself. Or if you've already downloaded the Kami app, you can send it through Kami, and it'll go straight to the Google Classroom in my inbox. If you have no idea what I'm talking about with Kami, and that's Kami, don't worry about it. I'm going to be going through it again and again through this week to try to get as many of us in the classroom as possible. Like, let's see, for my first period of Earth Science here, same thing, right? Some of you have already turned in. I already have someone who just turned it in again, and here we go. So I'm going to go ahead and start with the homework. So the homework, which is here, now I'm going to provide you with a video help for it. All right, give me a second. There we go. I'm going to open it with my Kami app so I can write on it, and you're right here along with me. I can see myself, so my hair's looking a little thick. I ain't got time to worry about how cute I look. It's really all about food. Me. It's about food, it's about me. All right, here we go. All right, so my second Earth Science class, we actually took the time to read this information. I am drooling, it doesn't fit. I do not delete videos, I keep going. All right, here we go. So let's see, my second period class, we were able to switch or read the actual reading out loud together, which is pretty cool. My first period class, we did not read it together. What I'm trying to do is put this over here. There we go. I like it better all this time. All right. So what I'm going to do is read it for you again. I'll actually do the entire reading for you. No, I'm not. That's a lot of reading. Actually, yeah, I will. It's only because I like to sign my voice. All right, let me just go ahead. Okay, so we're going to read this page and then answer the questions. I'll get you started on the questions. So we this week are talking about the layers of the earth and the scientific method and data analysis. That's three major things that we're going to be covering this week in class. So we're going to have to do the scientific method. We're going to have to do layers of the earth, or the earth structure. That's what this reading is about. And also learning about data analysis. My board is back up, by the way, first period. My board is back up. So I'll be able to use technology in the classroom. We are going to rock and roll and kill this. Right on. Okay. Here we go with the reading. Bring this down a little bit. There it is. Journey to the center of the earth. Reading comprehension. All right. And it says, we all call Earth home, but did you ever think about what our home is actually made of? The planet is approximately 6,400 kilometers from surface to center. But what makes us make up those kilometers of Earth? If we could travel through the layers of Earth, what would our trip look like? In order to make this trip, we would need a special vehicle that could travel through both liquid and solid rock, and that could withstand intense temperature and pressure changes. The deeper in the center of the Earth, the hotter it is, and the more pressure we will face. Then it says, in 1961, scientists drilled a hole 200 meters into the ocean's crust. They hope to, I think it's 200 miles in the ocean's crust. They hope to reach the Moho discontinuity. I think that's a word. Hey, you know what we're going to do? I'm not a reading teacher. We'll do the text to speech. Oh, yeah. Okay. Nope, not all that. I just need this word. How to sign it out. Oop. My music's still playing. One second. I've got to see how that word is really pronounced. All right, let's go from there. I can't even get anything to work. All right, never mind. We'll just keep going. Is that gonna work there? Oop. I'll figure out that part later. Anywho, I'm going to say discontinuity. Anyway. Unfortunately, the project was canceled after phase 1. At this time, we still do not have the technology needed to make it through the entire rocky layer of the Earth, let alone into deeper layers. So that's what the rest of that part says. And let me go ahead and continue reading. So here, oh, by the way, this is a nice picture of the Earth, and it has the different layers and everything is labeled over here, but we're going to be focusing on that the rest of this week. Okay, then this talks about S waves and P waves. So this sentence says, so how do scientists study Earth's interior if we can't get to through it? That doesn't sound like a good sentence. So how do scientists study Earth's interior if we can't get through it? That's incorrect grammar. Anyway. Seismologists are geologists who study seismic waves to learn about Earth. Studying the behavior of earthquake waves to gather data about Earth's interior is similar to using sound waves to see inside the human body. Observing seismic waves allows scientists to infer images of Earth's interior. Data has shown that seismic waves, whatever I said before, bend when they encounter sharp changes in density. There are different kinds of seismic waves, known as P waves, which can travel through liquids and solids, and S waves, which can only travel through solids. Studying these waves helps seismologists theorize the composition, thickness, density, and phase of the 4 layers of Earth. Now, I know there's a whole lot of words in there that you never heard before that's thrown in this sentence. Don't worry about it. You will get to know it. I'm going to put a word wall up on the board, and then you're going to know more about these waves as we continue this week, starting tomorrow, okay? Don't worry if these are just like a deep reading for you. You're not digging it. It's all good. I still got your back, no matter what. Let's start our journey to the center of the Earth. In order to make it through, we have to start with the part of the Earth that we live on, the outermost rocky layer called the crust. That's important. The layer can range from 5 to 40 kilometers, or kilometers, however you want to pronounce it, thick. The thickest section occurring at mountain ranges, and the thinnest section part of the ocean floor. The crust is separated into 2 parts: oceanic crust, which is the ocean floor, which consists mostly of dense rock, such as basalt, and continental crust, which is dry land, continents. which consists mostly of lighter and less dense rock, such as granite. We come to a boundary. Above this boundary, the rocks of the crust, below a layer of the hot rocks of the mantle. Together, these form a rigid, rocky layer of Earth known as the lithosphere, which averages around 100 kilometers thick. We continue into the mantle, where our vehicle encounters a hotter, softer material that is under increasing pressure. This must be the asthenosphere. Yeah, that's pronounced it correctly. The soft, hot, plastic-like layer of the Earth that is constantly flowing slowly by convection currents. Pieces of the lithosphere, float on top of the asthenosphere, and another solid layer of material lies below, making the mantle nearly 3,000 kilometers thick. Finally, we've made it to the core. Whew, it's so hot down here. There are two parts of the nearly 3,500 kilometers thick core, a liquid outer core and a solid inner core. The iron and nickel material in both layers of the core make up 1/3 of Earth's mass, but only 15% of the volume. The core is just slightly smaller than the moon. The molten metal outer core flows like a thick liquid, but there is so much pressure on the atoms of the inner core that they are pressed together into a dense ball of solid metal. We should probably get out of here before the enormous pressure of 5,000 Celsius temperature turns our vehicle into a solid ball too. Okay, so if you're not good with reading comprehension, I can understand if that sounds a little bit complicated, so I'm going to get you started and help you through with tonight's homework. So I'm expecting everyone to have this done tomorrow and be able to turn it in, especially if I'm going through it with you. All right? All right. So here, complete the chart below based on the information from Journey to the Center of the Earth. So it's composition. The composition talks about is what things are made of. What is it composed of? Composition, right? So the crust, talking about this information about the crust, and we can tell the crust is made of oxygen, silicon, aluminum, calcium, iron, sodium, magnesium, and potassium, okay? So, and how do we know that? You go up here, you find the crust, you can find that information that's all up here, okay? And most of it, some of it's not, that's why they fill it in for you. The mantle, made of silicon, oxygen, iron, and magnesium. The outer core, what information can we put here about the outer core? What is it made of? Let's find where it says outer core. That should be on this page somewhere. Let's see, the molten here, the lithosphere, and outer core, just below the mantle, inner core, outer core. There it is, that's inner core. So above the inner core should be the outer core. 2 parts thick core, a liquid outer core and a solid inner core. Ooh, that just told us something right here, that it's liquid. By the way, if you're using Kami, you can draw it in, the name. So we know that the outer core, see it right here? Liquid outer core is liquid. Or you can actually type it in if you wanted to as well. But like liquid. And you can make the text as big as you want to. Just helping you go through the Kami tools, which I'll be also showing you completely through this week too. So we got that. Anything else it says about the outer core? Let's see if I can find anything. 2 parts, a liquid outer core and a solid inner core. The iron and nickel material on both layers. Ooh, so both made of iron and nickel. Alrighty, so I'm going to add that in. I'm going to add it in with the text box. Iron, nickel. Right. And that means I can also put information on here too. Okay, liquid, iron, and nickel. And then, I didn't mean to do that part. So I'll throw that one away. Now let's talk about the inner core. Inner core is the same thing, a liquid outer core and a solid inner core. So we already know that the inner core is a solid. There we go. Also made of iron and nickel. And then just to put something else that's new here, you see this? The iron, nickel, and both. Let me move myself out of the way. Yeah, right. It says iron and nickel material in both layers of the core make up about 1/3 of Earth's mass, but only 15% of its volume. The core is just slightly smaller than the moon. And then it says the molten metal, which is melted metal, outer core flows like a thick liquid. But this is so much pressure of the atoms on the inner core that they press together into a dense ball of solid metal. Okay, so we have that one liquid. We have this one as a solid, but I like this part right here where it says, let's see, the core slightly smaller than this, slightly smaller than the moon. I just like that sentence. Slightly. S-L-I. Smaller than the moon. I just wanted to put something additional in there. There we go. So now I have that. Remember to click on the arrow in order to move around. Thickness of the crust. Ooh, okay. So I'm going to go back up here where it talks about the crust, and I'm looking for the thickness of the crust. Okay, so here we go. We have the outermost rock layer called the crust. Here we go. This layer can range from 5 to 40 kilometers thick. Well, there is your answer right there. Everybody see where that is? So we have whatever, that didn't work out well. Kilometers thick. Let me do it by this part. There, I'm talking about the crust. So that's what I would put down here. And I'll just use the pen. 5 to, what was that again? 40 kilometers. There it is. Okay. And then we're going to talk about the thickness of the mantle. And we'll go back up and find mantle. And change my colors here. And so, the crust is separated by the two parts, which is continental and oceanic. Mantle, here we go. Together, this form rich rock layer of the Earth known as the lithosphere. Okay. Here we go. This one is actually just the amount for the lithosphere. But remember, there's two parts to the mantle. The mantle has the lithosphere and the asthenosphere, or lithosphere, whatever. And the asthenosphere, which is, this must be the soft lithosphere. Okay, here, a piece of lithosphere float on top of the asthenosphere, and another solid layer of material lies below, making the mantle, there's the total that we need. The mantle in total, after these two parts put together, right, 3,000. So that's what I'll put here, different color, 3,000 kilometers thick. Here we go, right? So I'm going to leave the outer core and the inner core part, those were just separated, over here for you to answer yourself. Got it? Good. So states of matter. Now this part right here, this means solid, liquid, or gas. Okay, so SLG means solid, liquid, or gas. So we're talking about the crust. Is the crust a solid, liquid, or gas? Okay, so with the crust, remember there's two types of crust, oceanic and continental. What type of state of matter do you think oceanic is? Ocean is liquid, isn't it? So I would put for oceanic, that's what I would put in, put liquid. And I'll do it this way. Right, text box. Make it a little bit smaller. See, I'm using these tools so you can learn how to use them yourself as well. And I'll go to a 10 point. I can see 10. 10 is good. All right, here we go. So for oceanic crust, and I'll just put oceanic equals liquid. And then we'll do continental crust, native continent. So guess what that is? That's going to be a solid. Continental equals solid. Solid as a rock. Ooh, ooh. I think I'm done with some chocolate. Or chips. Now I'm ready to be. All right. So now I'm going to actually leave the rest of these for you. So mantle, again, is a solid, liquid, or gas, right? Outer core, solid, liquid, or gas. Inner core, solid, liquid, or gas. Make it any easier. All right. Now, question number 2, what happens to the temperature as we travel closer to the center of the Earth? We go back up here. Remember, we're pretending we're in a car. We're driving closer and closer to the center of the Earth, right? Okay. So as we get closer to the center of the Earth, gets hotter. So what happens as we go closer to the center of the Earth? Oh, that's right. I hear you. The temperature goes up, gets hotter. I can't spell what's that. Maybe this is just too small for me to see, which means I'm getting old as fuck. I'll do 14. How about 14? There we go. Temperature. There you go. So just as it goes up, which means it gets hotter. Right? What happens to the pressure as we travel down? Pressure, what happens to the pressure? So if you look here, we should probably get out of here before the enormous pressure of the 5,000 degrees Celsius temperature turns our vehicle into a solid ball. So what happens to the pressure is it becomes heavier, more pressure. Yes, it becomes higher, more pressure. It becomes higher. What rocks make up most of Earth's crust? Oceanic and continental. If you go back up here, oceanic and continental. Remember those words right here. Here, you can tell me what kind of rocks, okay? Now, I will say that this is your key area. Look at this, oceanic crust, which consists mostly of that type of rock, or continental, that type of rock. I'm moving on. So that means now, making it easier. You know what to put here. All right. So what do you think the oceanic crust contains, or excuse me, why do you think the oceanic crust contains rocks that are more dense than rocks that are found on land? Remember, the more dense something is, the heavier it is. Think about that. And I want you to try to give me a good answer for that. The more dense something is, the heavier it is. The question again, why do you think the ocean crust contains rocks that are more dense than rocks found on land? Why do you think oceanic crust contains rocks that are more dense than the rocks found on land? Think about what's on the bottom of the seafloor. All right, so now, what makes up the lithosphere? That question I'm going to leave you on your own too, because you have the lithosphere right here. It tells you everything that's made up with it. And then last but not least, the plates of the lithosphere move slowly because they float on top of the asthenosphere. Okay? That's important too. See that? That helps with this question too. Describe how the molten material in the mantle causes this movement of the lithosphere plates. Okay, so what's going on? Describe how the molten material in the mantle causes the movement of the lithosphere plates, and that's because of convectional currents. I already had that, of course, memorized, but you can find that information up here where it talks about the currents. Pieces of the lithosphere float on top of the atmosphere, and another solid layer of material lies below, making the mantle nearly 3,000 kilometers thick. Go up a little bit further, and it talks about the currents. There it is. This must be the atmosphere of the soft, hot plastic-like layer of the Earth that is constantly flowing slowly by convectional currents. Convectional currents. Okay, this ends your homework for this evening. I will see everybody tomorrow, and make sure you go through and fix all that, and then I will just see you tomorrow. I hope you had a good time like I did. Peace.